Good morning. This is Dr. Davamani, Assistant Professor, Computer Science, Shift 2 Department. Today we are going to have the video presentation on the topic of ensemble learning in the course Machine Learning. So let me see an introduction about ensemble learning. So traditional learning methods, so many methods which are available in order to create a best hypothesis or the best classifier, which is chosen to form a hypothesis space that is used to make more predictions. So ensemble learning, which is nothing but ensemble, that is nothing but a small group of or the collection of learning models. So by combining various small group of models in order to produce a better learner or in order to produce a better classifier. So that's why they have given a formal definition: select a collection of hypotheses and combine their predictions in order to have a best hypothesis or in order to have a best classifier. For example, generate 100 different decision trees in order to 100 different decision trees from the same training data set or the different training data set and have them vote on the best classification for a new example. New example in the sense, for the new transactions we have to classify with the correct labels. So this is how we have to learn. This is how we have to ensemble various learning models. So our key motivation in this ensemble learning is to reduce the error rate. Reducing the error rate in the sense, avoid the misclassification. So this learning ensembles, we have to learn multiple alternative definitions of a concept, of a particular concept, using a different training data, or we can use different learning algorithms. After using learning algorithms, combine the decisions of multiple definitions. For example, weighted voting. So if we are having the best classifier, then we can give the best greater number of votes. The entire training data, which is divided into various data set, like training data set 1, training data set 2, etc., training data set M. So for each training data sets, we are having a separate learning models. We can use it: learner 1, learner 2, etc., learner M, and the model 1, model 2, etc., model M. So by combining all the models, we can applying various training data sets and finally producing a final model. So next, let's see the value of ensembles. Value of ensembles, which is nothing but no single algorithm which wins all the time. No single algorithm spins all the time in the sense, single result which will not be accurate always. So that's why they are saying we combine a multiple independent and diverse decisions, each of which is at least more accurate than random guessing, so that automatically there are errors which can be reduced. See, like we can see the weather forecast. This is the first row, which showing the reality of the classifications. So here some examples which have been classified as like a devil, some examples which have been classified as smiley face. And the first classifier, every row number as 1, 2, 3, 4, 5 are classifiers. The first row, which has wrongly classified 3 examples, and second classifier which has again misclassified 3 examples, and similarly third classifier and 4 and 5. So by combining all these classifiers, by ensembling these learning models, we are getting the classifications which are very similar to the reality. So that's why we the ensemble learning which proves as a better model. So another way of understanding of this ensemble learning, which is a way of enlarging the hypothesis space, not only producing a better classifier, and also our objective is to cover the enlarging hypothesis. Enlarging a hypothesis space, our hypothesis space in the sense, we are trying to cover the more number of transactions, more number of examples. So the ensemble itself, it is a hypothesis, and the new hypothesis space is the set of all possible ensembles which can be constructed to form a hypothesis of the original space. So here there are three linear threshold hypotheses. So initially we have taken the three linear threshold hypothesis. Threshold hypothesis in the sense the random hypothesis, we are taking it as a better hypothesis. By ensembling all these three linear threshold hypotheses, the combined ensemble classifier which classifies as positive in example, which is classified positively, be all the three. Yes, which was automatically be a positive within the examples which are in between the triangle, which are considered as a positive by the ensemble classifier. So there are so many methods which are available in order to implement this ensemble learning. The first method is a bagging model. Bagging, which is nothing but the abbreviation of bootstrap aggregation, which create an ensembles by bootstrap aggregation. What does mean by bootstrap aggregation? That is nothing but repeatedly, randomly resampling the training data. So we are having an initial training data. Every time we have to resample it. We have to change our training data and then applying into the new data models. So bootstrap, which is nothing but how we can change, how we can resampling the training data, in the sense we have to draw n number of items from the X database with a replacement. So what does mean by bagging? Yes, we are going to train m different number of learner or the models on m bootstrap samples, and then finally combine the outputs by voting. So whichever model having the majority vote, that will be considered as a ensemble learner. So ensemble learner, which automatically decreases the errors by decreasing the variance in the results because of the unstable learners. Unstable learners in the sense the algorithms which output can change dramatically when the training data is slightly modified. So automatically the error rate which is reduced. And this is an algorithm bagging aggregate bootstrapping. So given a standard training set D of size n, and then for each and every model from 1 I equal to 1 to m, 1 2 3 4 5 etc. m. So various learners, m number of learner model is there. For each and every model we are going to apply this training set of D. So draw a sample of size n star which is less than n from D uniformly and with replacement. And then we have the learn classifier CI. CI, which is nothing but I ranges from 1 to m, because m number of models is there, m number of classifier is there. So we are going to apply these training data set to C1, C2, C3 etc. Cm. So final classifier is an ensemble, is a vote of C1, C2, C3 etc. Cm. So final classifier, ensemble classifier, which automatically increases the classifier stability and reduces the variance. So this is all about. So next one is boosting. Boosting, which is nothing but we are going to give the boost for the weak learners. So there are learning models which can be classified as strong learner and weak learners. Strong learner, this is the machine learning algorithm's objective itself, it is going to produce a strong learner. Take a labeled data for training and produce a classifier which can be arbitrarily accurate. So for any type of training data set, the learner, if it produces accurately, if it produces accurate classification of labels, then we can say that classifier is a strong learner. Weak learner, this is nothing but produces a classifier which is more accurate than random guessing. Not always. So that kind of learner we can call it as a weak learner. So our objective of this boosting method is we have to take a weak learner and then we have to convert these weak learners into a strong learner by changing the weights, so that automatically the votes will be increased. So if the number of votes will be increased, then the weak learner will be automatically become a strong learner. So weak learner. So weak learner, how we can say a particular learner is a weak learner? which only needs to generate a hypothesis with the training accuracy is greater than 0.5, not more than that. That is less than 50% of error over any distribution. So those kind of learner is considered as a weak learner. That is very easy to construct a weak learner when compared with strong learners. Yes. Here, yes, of course, we are having a question. Can a set of weak learners create a single strong learner? Yes, more than one weak learners we can combine into a single ensemble, and then if we are applying various training data sets, then automatically this ensemble learner will become a stronger learner. Instead of sampling, so as in the bagging what we are doing it, so we are resampling the training data set. Here instead of resampling, reweigh the examples. Here we are assigning the weight as differently for every iteration, so that automatically the weight has been changed and the number of votes also be changed. Examples are given weights at each iteration. A new hypothesis is learned and the examples are reweighted to focus the system on the examples that are most recently learned classifier got wrong. So if we have changed the weights and then again applying into that learner model, there is a chance of giving the positive results or positive labels. So weak learner which automatically changed into a strong learner by changing the weights. So final classification which is based on the weight, that is out of weak classifiers. So this is how the boosting and bagging, which are the suitable methods in order to create an ensemble learner. So thank you so much for watching this video. So let's see the next rest of the topics in the next video. Thank you.